Hello everyone, I'm Akram Ijdal and I'm going to present you the work done for the comparison of MetaMap, CTX, Cypher, and ECMT to annotate breast cancer patient summaries. This work was done in the LIMIX, the Laboratory of Medical Informatics and Knowledge Engineering for eHealth, and was financed by the University Institute of Healthcare Engineering of Sorbonne University. So the clinical context is the breast cancer, which is the most common cancer among women, with nearly 1.5 million new cases per year in the world. Multidisciplinary tumor boards, or MTBs, are meetings that have been introduced to provide a collaborative and multidisciplinary approach to cancer care. It is proven that the introduction of MTBs that improved the cancer care. However, their benefits are now being challenged because there is a lot of clinical cases to discuss and lack of time to discuss all the cases. Clinical decision support systems, or CDSS, are systems that embed clinical practice guidelines. It is shown that the use of CDSS does improve the compliance of the decisions during the MTB with the clinical practice guidelines. However, we still mention a lack of use of CDSS in clinical routine. And during the evaluation of Desiree, which is a clinical decision support system for breast cancer management, we found that the system does not provide recommendations for some clinical cases and sometimes gives the wrong recommendation. We classified these clinical cases as complex clinical cases. Our global objective is to create a decision support systems with two modules of decision support based on the complexity of the clinical cases. So the aim is to start from the breast cancer patient summaries, or BCPS, to implement the complexity detection algorithms, and then to provide decision support system according to the complexity. For the non-complex cases, as they are covered by the CPGs, we give a guideline-based decision support system. And for the complex cases, as they are not covered by the clinical guidelines, we give a case-based decision support systems. So what we need to implement such algorithms are structured data. However, the problem is that the breast cancer patient summaries, or BCPS, are expressed in narrative, textual, and unstructured clinical notes. There is a lack of annotated BCPS, and there is a lack of time to manually annotate all the BCPSs. So our aim in this work is the use of automatic semantic annotators to index the breast cancer patient summaries. So our objective is first to identify the relevant automatic annotators, then to implement them on a corpus of textual unstructured BCPS, and finally to assess whether the annotators are redundant, complementary, and identify which is the best annotator. So we start from natural language textual unstructured BCPS written in French. We run the annotators on each BCPS and obtain structured data from each system, and then we compare the result and assess the efficiency of each annotator. So as materials, we have been using two widely used English annotators. First one is MetaMap. It's a system developed by the National Library of Medicine to map biomedical text to UMLS concepts. It is based on a hybrid approach combining natural language processing, knowledge-intensive approach, and computational linguistic techniques, and it does map the concepts to the UMLS QE. The second system is CTX, which stands for Clinical Text Analysis and Knowledge Extraction System. It's a system that uses rule-based and machine learning techniques to extract information from clinical text, and it's also indexed with the UMLS, so it extracts the clinical concepts according to the UMLS concept unique identifier. As we work on French data, we also use two French annotators. The first one is Cypher. It stands for Semantic Indexing of French Biological Data Resources. It is an openly available web service that enables the recognition and the contextualization of the clinical text, and it works with the relevant biomedical ontologies. It is also indexed with the UMLS, so it extracts the concepts according to the UMLS. And finally, the last system is ECMT. It stands for Extracteur de Concept Multiterminologique. It is a system based on back-of-words algorithms and textual indexing. It works with 7 French medical ontologies and terminologies. And however, ECMT is not indexed with the UMLS, so it extracts the concept but not the UMLS identifier. We also worked on a corpus of breast cancer patient summaries. We had a sample of nearly 650 BCPS available as textual and unstructured documents. The breast cancer patient summaries contain different types of information regarding the patient. It starts with the reason of presentation, then the type of tumor, then the biometric data, the personal history, the family history, the TNM classification, etc. However, there is a lot of use of acronyms and abbreviations in the text, and also a use of specialized terms and terms according to the experts who write the notes. So as we had a lot of abbreviation, we started first by a pre-treatment of the breast cancer patient summaries. We did scrapping on the web, on Wikipedia and Doctissimo to create a database of French oncology acronyms and their definition. Once we had this database, we created algorithms that look for the acronyms and the abbreviation in the text and replace them with their definition. We had, as a result, the same French breast cancer patient summaries, but without acronyms and abbreviation. And then, as we work with the English annotators, we used the translation model, the Opus MT translation model from French to English to translate the documents. And we had, as a result, the same notes written in English. So once we had the French clinical notes and the English clinical notes, we run the systems on each note. We had different output according to the system. So for MetaMap, we used an XML parser to extract the UMLS concept unique identifier. For CTEX, there was XME, so we implemented an XME parser. For Cypher, the output was in JSON, so we implemented also a JSON parser. And for ECMT, as it doesn't give the concept unique identifier of UMLS, we reused Cypher on the words and the concepts extracted by ECMT, and we extracted then the concept unique identifier from the Cypher extraction that we did on the ECMT concepts. So as a result, MetaMap was the system that extracted the most concept, a lot above the other systems, with nearly 16,000 concepts extracted on 25 breast cancer patient summaries. It was followed by Cypher with nearly 4,000 concepts extracted, and ECMT with half of Cypher. And finally, CTEX was the system that extracted the least number of concepts. We also studied all the combination possible between the systems. So each system alone, 2x2, 3x3, and the 4 systems together. And the table below shows the results for 4 systems. And we can notice, for example, that for the systems that are used within the same language, the number of concepts extracted are higher than a combination between 2 different languages. So for example, ECMT and Cypher and MetaMap and CTEX extract more than the combination of more than 1 language system, and also with the combination of 3 systems or the 4. We also wanted to study the semantic types that are extracted by the systems. So we found that the therapeutic and the prevention procedures were the semantic type that is the most extracted in all the patient summaries. So at the end, MetaMap was the most efficient annotator because it extracted a lot more concepts than the other systems. The most frequent concepts extracted by the 4 annotators were therapeutic procedures, pathologic functions, diagnostic and imaging procedures, and also body parts and associated disease. These are concepts that can be used to provide structured data. And finally, the less frequent concepts were related to tissues, cell functions, or the lesion information. We also noticed that each annotator can extract different specific categories of information. MetaMap could produce more information like the HER status, the hormonal receptors, the lesion size, etc. SEMT could annotate phrases that are specific to the French language and that are only annotated with French terminologies. We couldn't find the UML SQE for this concept, so it can be important to have them in our structured data. Cipher offers access to multiple terminologies, and we also had some concepts that were extracted by Cipher and not by the other annotators, because it uses also Muevo, which is a terminology specific to the French oncological field. And finally, we explained the lack of efficiency of CTX by the fact that the pipeline of CTX can be customized according to the clinical needs. So we believe it can have a lot more efficient results, and it was shown because it was used for breast cancer phenotyping in the DeepFi project. In conclusion, the use of automatic annotators can be time-saving and efficient for structured data extraction from the breast cancer patient summaries. The combination of the result from annotators might permit to retrieve complementary information, and also the use of automatic translation can be practical because it can permit to benefit from other languages tools. And finally, the result of the annotators might be enhanced by additional information. So as I said later, the breast cancer patient summaries contain specific informations, and these informations are put in a specific order. So it starts with the reason of presentation, then the type of tumor, then the biometric data, then the personal history, then the family history, etc. And using this knowledge may help to put some information on the extracted data from the annotators, so to have a more structured data and use this data on AI algorithms and on decision support systems. Thank you for your attention, and I'm waiting for your question. Thank you.